All right, this video will cover section 5.7 dealing with polynomial equations. We're solving each of these equations, the first one being 4x squared minus 25. Notice immediately that this is a difference of perfect square numbers. We can identify the a term and the b term that's being squared. In this case, 4x squared, that a term. What are we squaring in order to get 4x squared? That's 2x. 2x. And the b term is 25. What do we square to get 25? We square 5. So we would substitute into that format of a plus b times a minus b in order to factor this term. So our a plus b would be 2x plus 5. Our a minus b would be 2x minus 5 equals 0. We just carry down the equal sign and the 0. Now to solve, we're going to set each of these factors equal to 0 and solve. The first factor, 2x plus 5 equals 0. We'll solve this equation by subtracting 5 from both sides. And then we'll get 2x on the left equals 0 minus 5, which is negative 5. And then lastly, we're going to divide both sides of this equation by 2. The 2's will cancel on the left, leaving x, and that equals negative 5 halves. Or we take that second factor, that 2x minus 5, and set it equal to 0 and solve this equation. We're going to add 5 to both sides of the equation first. The 5's will cancel on the left, leaving 2x equals, on the right side, 0 plus 5 gives us 5. Then we're going to divide both sides of this equation by 2. The 2's will cancel on the left side, leaving x, and that equals 5 halves. So our two solutions will be x equals negative 5 halves or positive 5 halves. So you factor and then you set each of the factors equal to 0 and solve. All right, let's look at the next example. We have 9x squared plus 1 equals 6x. First of all, we need to get the 6x over to the left side of the equation with the remaining terms because we want our equation equivalent to 0, equal to 0. Once we subtract 6x from both sides, the 6x will cancel on the right, leaving 0. When we subtract 6x on the left side, we're left with 9x squared minus 6x plus 1. From here, we're going to factor. So we'll factor 9x squared using 3x and 3x. And we're going to factor 1 using negative 1 and negative 1. We're using minus for both terms because our middle term is negative. And we know a negative times a negative is positive. But when we add those two negative terms together, we'll get negative 6. Now we're going to set these factors equal to 0. We have 3x minus 1 and 3x minus 1. We have the same factor in both set of parentheses, so we only have to solve one equation. So we set that factor, 3x minus 1 equal to 0, and we're going to solve this equation. Add 1 to both sides of the equation. The 1's cancel on the left side, leaving 3x, and on the right side, 0 plus 1 gives us 1. And then we're going to divide both sides of this equation by 3. The 3's will cancel on the left side, leaving x, and that equals 1/3. All right, let's look at the next example. We see that our equation is not equal to 0 again, so we're going to subtract 64 from both sides of the equation. The 64's will cancel on the right side, leaving 0. And on the left side, we have 4x squared minus 64. This is a difference of perfect square numbers, but before we do that, we're going to factor out our greatest common factor. We're going to factor 4 from both of these terms. When we factor 4 from 4x squared, we get x squared in parentheses. And when we factor 4 from 64, we get 16 in parentheses. Now we'll keep this 4 outside parentheses, and the x squared minus 16 inside the parentheses, that's a difference of perfect square numbers. Our a term is going to be x, and our b term is going to be 4. So we factor using x plus 4 and x minus 4. Now we'll set both of these factors equal to 0 and solve the equations. So x plus 4 equals 0. We solve by subtracting 4 from both sides of the equation. The 4's cancel on the left, leaving x. And on the right side, 0 minus 4 gives us our first solution, negative 4. Our second factor, x minus 4 equals 0. We're going to solve this equation by adding 4 to both sides of the equation. The 4's will cancel on the left side, leaving x. And on the right side, 0 plus 4 gives us 4. So our two solutions, x equals negative 4 or positive 4. All right. In our next example, we have 11m squared minus or equals 31m plus 6. Now we do need to carry that 31m and the 6 to the left side of the equation. So we're going to subtract 31m and we're going to subtract 6 from both sides of this equation. So we're moving these terms. They're canceling out on the right side, leaving 0. And on the left side, we're left with 11m squared minus the 31m and minus 6. Now we're going to factor this 11m squared using 11m and m. And we're going to factor this minus 6 using positive 2 and negative 3. Once we get our two factors, we're going to set each of these factors equal to 0 and solve the equation. So this first factor, 11m plus 2, we wrote over here, 11m plus 2 equals 0. We would solve by starting with the subtraction. We're going to subtract 2 from both sides of this equation. And when we do that, the 2's are going to cancel on the left side, leaving us with 11m. And on the right side, 0 minus 2 gives us negative 2. Then we're going to divide both sides of this equation by 11. The 11's are going to cancel on the left side, leaving m. And on the right side, we have negative 2 11's. Or our second factor was m minus 3. We take m minus 3 and set it equal to 0. And then we're going to solve this equation by adding 3 to both sides of the equation. The 3's cancel on the left side, leaving m. And on the right side, 0 plus 3 gives us 3. So here's our solutions, negative 2 11ths or 3. All right, in this next example, notice we have a minus in front of our leading coefficient when it's on the left side. So what we do in this case, to make this highest exponent, x squared, to make it positive, we're going to add x squared to both sides of the equation. We're going to move it to the right side of the equation. And because we're moving that x squared over, we're also going to add 7x to move the 7x to the right. Now when we do that, the 7x and the x squared are going to cancel on the left side, leaving 0. On the right side, we're left with x squared. We're writing these terms in decreasing order. We have the highest power or the highest exponent first. So x squared goes first, then plus 7x, and then plus 10. From there, we're going to factor that x squared, our first term using x and x, and we're going to factor 10 using 5 and 2. Now we're going to set both of these factors equal to 0 and solve the equations. So x plus 5 equals 0. We subtract 5 from both sides of this equation. We'll get x equals negative 5, or our second factor was x plus 2. We set x plus 2 equal to 0, and we're going to subtract 2 from both sides of the equation. The 2's will cancel, leaving x equals negative 2. So our two solutions, negative 5 or negative 2. All right, in this example, we're going to use this graph. You see this parabola. The graph of this function, f of x equals x squared plus x minus 6, is here. And we want to know, we have the graph here. We want to know where the graph crosses that x-axis. When we solve these equations, like we did before, we got these x coordinates. What we're doing is we're producing these x-intercepts. We're determining those points where the line of the parabola is going to cross the x-axis. So you're essentially just factoring, just like you did before, and setting both of those factors equal to 0 to get those values for x. So what you want to keep in mind is that in the graph of a parabola, when you solve to find these zeros, when you factor, solve to get those factors, like in this case, we would factor x squared using x and x. We factor the minus 6 using a positive 3 and a negative 2. And then we set both of these factors equal to 0. So x plus 3 equals 0, or x minus 2 equal to 0. And when we solve these equations, we get positive 2 because we're going to add 2 to both sides of the equation on the right side. The 2's will cancel, so we'll get x equals 2. Or when we solve this equation on the left side, we subtract 3 from both sides. The 3's will cancel, we'll get x equals negative 3. So negative 3 or positive 2. Those are the solutions we get. But when you're looking at a graph, you can get those same solutions by looking at your x-intercepts. You see how we cross the x-axis right here at 2, and we also cross again over here at negative 3. So we can get those zeros or those solutions to this function by also viewing the graph. All right, here in this example, we see x cubed equals 16x. We need to carry this 16x to the left side of the equation, so we're going to subtract 16x from both sides of the equation. And when we do that, the 16x will cancel on the right side, leaving 0. We'll carry down the 0. On the left side, we'll have x cubed minus 16x. We have a GCF, a factor that we can factor from both x cubed and 16x, and that's x. So we factor x from x cubed, and we'll get x squared in parentheses. We factor x from the minus 16x, and we'll get minus 16 in parentheses, equals 0. Just carry down your x, and then look at your x squared minus 16. This is a difference of perfect square numbers again. So we can identify our A and B terms. Our A term, what are we squaring to get x squared? X. And what are we squaring to get 16? That's 4. So we factor as x plus 4 and x minus 4. So we're going to set each of these factors equal to 0 and solve the equation. So here we have our x plus 4 equals 0. We're going to solve this equation by subtracting 4 from both sides of this equation. The 4's are going to cancel on the left, and we're left with x. On the right side, 0 minus 4 gives us negative 4. One of our solutions is negative 4. And that next factor, x minus 4, we set equal to 0, and we're going to solve that equation by adding 4 to both sides. The 4's will cancel on the left, leaving x, and on the right side, 0 plus 4 gives us 4. Now, the last solution that we have, look, in front of our parentheses, we had x by itself. So we also want to set that x equal to 0. So one of our solutions will also be 0. So we have 3 solutions. X could be 0 or negative 4 or positive 4. Now you determine your number of zeros based on your power. We had a higher power this time. We had x to the 3rd power. That lets us know we have 3 solutions, 3 possible solutions. Similarly to the next example, we have x cubed again, plus 5x squared, and it equals 9x plus 45. So we're going to combine these like terms first. Combine the terms to the left side. We want to collect all the terms on the left. So we're subtracting 9x from both sides and subtracting 45. When we do that, the 9x and 45 are going to cancel on the right side, leaving us with 0. Now on the left side of this equation, we have x cubed plus 5x squared minus 9x minus 45. With 4 terms, you want to factor by grouping. So we group together, the first two terms and the last two terms, and we find our GCF, our factor, our greatest common factor that we can factor into both of the terms. From the first two terms, we can factor x squared. When we factor x squared, from x cubed, we get 1x in parentheses. And when we factor x squared from 5x squared, we get 5 in parentheses. Minus, from 9x and 45, we're able to factor out that minus because both of them have a negative sign. We factored out negative 9 from 9x, and we got x in parentheses. We factored the negative 9 from 45, and we got 5 in parentheses. Now, what you see here is outside of your parentheses, you have x squared minus 9. So that will be one of the factors of our solution. Now this example, this should have been a plus 5 as well. Notice that we have x plus 5 and x plus 5 in parentheses. That factor that we share, that's going to be the second part of our solution. So we're left with the x plus 5 times x squared minus 9. This x squared minus 9 can be factored further because this is a difference of perfect square numbers. We can identify the a and the b terms. X to the second power is our a term. What are we squaring in order to get x squared? That's our x and our x. So this is a and a. Our b term is 9. What are we squaring in order to get 9? That's 3. So we replace that x squared minus 9 with x plus 3 and x minus 3. Now after we're done factoring, we don't stop there. We're going to set each of these factors equal to 0 and solve. So first, our x plus 5 equals 0. We're going to subtract 5 from both sides of this equation. The 5s will cancel. On the left side, leaving x, and on the right side, 0 minus 5 gives us negative 5. So one of our solutions is negative 5. Or we're going to take that next factor, x plus 3, and set it equal to 0 and solve. We're going to subtract 3 from both sides of this equation. The 3's are going to cancel. On the left side, leaving x. And on the right side, 0 minus 3 gives us negative 3. So our next solution is negative 3. And then lastly, that x minus 3, we set that equal to 0. To solve, we're going to add 3 to both sides of this equation. The 3's are going to cancel. On the left side, leaving x. And on the right side, 0 plus 3 gives us 3. So our three possible solutions, negative 5, negative 3, or positive 3. All right, in this example, we're told that the height in feet reached by a baseball t seconds after it has been hit is given by this function. H of t equals negative 16t squared plus 88t plus 4. Determine when the baseball, when will it be 100 feet in the air? So we're trying to figure out when is it going to reach this height of 100 feet. So we want to substitute 100 for h of t. This h of t is the function that gives us the height after a certain amount of time. So we're going to substitute h of t with 100. Now we're rewriting this function, but where h of t is, we're replacing 100. And it equals, everything on the right will stay the same, negative 16t squared plus 88t plus 4. We're just going to solve this just like we would in the previous example. Now what we need to do is collect all our terms on one side of this equation and set it equal to 0. Our leading coefficient is negative when it's on the right side of the equation. So we're going to add 16t squared, and every other term will be moving to the left side. So we're adding 16t squared, we're subtracting 88t, and we're subtracting 4. Now that'll cancel the terms from the right side of the equation and take them to the left side of the equation. So on the right side, we're left with 0. But on the left side, we had 16t squared. Remember, we added 16t squared minus 88t. And then that minus 4, we had a 100 on the left side. So 100 minus 4 leaves us with 96. From here, we factor out our greatest common factor. We can factor 8 from each of these terms. When we factor 8 from 16t squared, we get 2t squared. When we factor 8 from minus 88t, we get minus 11t. And when we factor 8 from 96, we get 12. So in parentheses, that 2t squared we factored using 2t and 1t. And the 12 we factor using minus 3 and minus 4. Now we're going to set each of these factors equal to 0 and solve. So our 2t minus 3 equals 0, or t minus 4 equals 0. We'll solve both of those equations. On the left, we're going to add 3 to both sides of the equation, and then we're going to divide by 2. And when we do that, we'll get t equals 3 halves, or on the right side, we're going to add 4 to both sides of the equation, t equals 4. So t will be at 100 feet at 2 points in time, at 3 halves of a second and at 4 seconds. That's the last example from this section. We'll stop here.